Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start a new topic, which is chapter number 4, mathematical expectation. So in mathematical expectation, we will learn some subtopic, which is we will learn how to calculate expected value, right? Expected value for discrete random variable, expected value for continuous random variable, and then we will learn how to find mean and standard deviation using moment and moment generating function, right? So the purpose of expected value for this topic is to find mean and standard deviation, right? So the concept of mathematical expectation is based on the concept of game, of chance, right? So most statistical analysis often ask to calculate average of a random variable of the experiment. So since most of the statistical analysis require to calculate random average of random variables of experiment, so one of the method to calculate average is by using expected value, expected method, right? And another one is by using a moment and moment generating function based on certain distribution. So the expectation of mean, so if you look at here, mean score is the mean of random variable x and often write as mu x or mu, right? Most statisticians agree to refer mean of a random variables x as a mathematical expectation, right? Or expected value of x. So the symbol for expected value of x is E with x, capital letter of x. So this is also equal to mean, right? So by looking at the definition, let x be a discrete random variables and fx is the value of probability distribution at x, and the expected value for this random variable, remember this is a discrete random variable, right? The expected value for a discrete random variable is a summation of x multiplied with the probability of x. So we can rewrite this one as x equal to the summation of x multiplied with probability of x, right? So this is the general formula for expected value of x, right? So for the general formula, this is a simplified formula, sorry. This is the general formula is expected value of x power of I is equal to the summation of x power of I multiplied with probability of x, right? So it can be replaced, if you can see, x power of I should be multiplied with the probability value, right? It's a multiplier for probability value, right? If you replace the value inside the expected notation, let's say you replace with some formula, right? So it will be summation of gx multiplied with probability of x. So this gx, the multiplier of x should be multiplied with the probability value, right? So now look at example number 4.1. In example number 4.1, so given the following probability distribution function for a discrete random variable x, right? So we have from value of x from 0 until 6, 1, 2, or 0, 1, 2, 3, 4, 5, 6 with its probability value. So now we want to find the expectation of x, right? The expected value of x, which is also equal to mean, right? So by definition, the expected value of x is equal to the summation of xi multiplied with probability of xi, right? So by looking at this formula, so we just input the value, plug in the value into the formula. So when x equal to 0 and the probability of x equal to 0 is 0.1 plus when x equal to 1, the probability of x equal to 1 is 0.15 plus 2, 0.2 plus 3, 0.25 plus when x equal to 4, probability is 0.2. When x equal to 5, probability is 0.06. And when x equal to 6, the probability is 0.04. So the value here should be equal to 2.64. Right. So the value, the expectation of x, the expected value of x is 2.64, which is also equal to mean of the distribution. Right. So the mean also equal to 2.64. Are you clear with this one? Right. Very simple. We just follow the formula. Right. So now look at example number 4.2. In example number 4.2, in one special game, a man is paid 6 ringgit if he get all head or all tails when the 3 coin are toes, right? So he need to pay 4 ringgit if either 1 or 2 head show, right? What is the expected gain? So to solve this problem, first we need to find the sample space for this game, for this experiment. So to get the sample space, we need to draw a tree diagram lah. So the tree diagram for a coin, either head or tail. Head, tail, head, tail. Right? So you need to have all the sample space. So this is one of the way to get to know the sample space that we have. So next, we need to determine, list down the sample space. The first one is triple H, HHT, HTT, sorry, HT, H, and then HTT. The next one, THH, THT, TTH, and last one is TTT. So this is the sample space available for this experiment. So next, what you need to do is to distribute this value, the sample space, into a probability distribution. So we have S, and then we need to determine what is our random variables and what is our probability distribution. Right. So the first one, H, you just copy all the sample space back to the probability distribution table. Right. So this is the first one, HHT, HTH, HTT. The next one, THH, THT, TTH, and the last one is TTT. Right. So now let's determine our random variable. So in the question says, in the statement says that he will get paid when he get all head or all tails. So means that we can set whether x to be all the number of tail, and we also can set x to be number of head. So let we decide x to be number of head, right? So this one going to be 3, 2, 2, 1, 2, 1. This is 1 and 2, 0, right? So the probability for 3 head is, so you can get from the tree diagram. So the first probability of hit is 1 over 2. The second one is 1 over 2. The third one is 1 over 2. You need to multiply these three probability, then you will get 1 over 8. And all of this is 1 over 8. Right? So next, once you have done with this one, so just distribute it, tabulate it into a probability distribution table. Right? Probability distribution table have two rows, which is the first one is X and the second one is a probability of X. So we only have X equal to 0, X equal to 1, 2, and 3. So we just distribute this. This is the probability in the value of X 0, 1, 2, and 3. And don't forget total, right? So when X equal to 0, the probability of X is 1 over 8 because we only have one X equal to 0, right? So when X equal to 1, we have 1, 2, 3. 3 event X equal to 1. So we need to plus 1 over 8, plus 1 over 8, and 1 over 8. So this one should be equal to 3 over 8. Same goes to X equal to 2 is 3 over 8 and X equal to 1 is 1 over 8. The total should be equal to 1. Right. So now we already done the probability distribution table. So the next step is we need to distribute the reward, right? Distribute the reward or the expected the value of gain, right? So he will get paid when he get all tails. This is RM6 and all head. So this is the reward lah, right? He will get paid when he get all tails, which is X equal to 0, and he will get paid when he get all head, when X equal to 3. So then he will need to pay when the number of head is equal to 1. So this is negative 4. He will need to pay, or the number of head is equal to 2, right? So now we want to calculate the expected of reward or the expected of gain lah. This is gain, right? So reward again, right? So this one should be the summation of reward multiplied with the probability of reward, right? So when he get reward 6 ringgit, the probability is 1 over 8, and plus negative 4 multiplied with 3 over 8 plus negative 4 multiplied with 3 over 8 plus 6 multiplied with 1 over 8. Right? Remember the same concept, eh? When when reward equal to 6, then the probability of reward 6 is 1 over 8. When reward is negative 4, to get the expected value of reward, so you need to input all the value into the expected value, and then this will lead to RM 0. So means that when he, on average, he will not gain anything lah, right? So this is what the expected value mean for lah, right? So now, can we continue to the next example? Example number 4.3, right? Given the following PDF for discrete random variable X, right? This is a same problem, right? So we have X equal to 0, 1, and 2, and the total value of X is equal to 1. So now we want to find the expected value of X. So using the same formula, X multiplied with probability of X. So this one should be 0 multiplied with 0.2 plus 1 multiplied with 0.6 plus 2 multiplied with 0.2. So this one should be equal to 1, right? And then the expected value of X square, it should be equal to the summation of x power of 2 multiplied with probability of x, right? So this one should be 0 power of 2, 0.2 plus 1 power of 2, 0.6 plus 2 power of 2, 0.2. So this one should be equal to 1.40, right? Okay, are you clear with this one? Very simple, right? So we just need to understand the formula and just plug in the value into the formula, right? So this is expected value is equal to x bar, right? Expected value of x power of 2 doesn't mean anything, right? So we will get using expected value of x power of 2 to calculate variance later, right? So now look at the definition, right? As I said before, the general formula for the expected value of x power of I is equal to the summation of x power of I multiplied with probability of x. So this formula only applies, right, for discrete random variable, right? So when you have a continuous random variable, then we cannot do use this formula, right? Because in continuous random variable, we need to integrate, right? So as in this formula, whatever in the bracket will be the multiplier of the probability, right? Whatever in the bracket will be the multiplier of the probability, right? So look at the definition. If x is a discrete random variable and fx is the value of the distribution function x, the expected value of random variable gx is given by the expected value of gx equal to the summation of gx multiplied with fx. So whatever value in the bracket will be the multiplier of the probability value, right? So the formula expected value of gx is equal to the summation of gx multiplied with fx, right? So now look at example number 4.4. If x is the number of point roll with a balanced die, find the expected value of gx equal to 3x squared plus 1, right? So now we know that x is the number of point roll with a balanced die. So the sample space for a die is 1, 2, 3, 4, 5, and 6. So we need to draw a probability distribution table, right? To 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 make sure we understand the distribution of the probability. So this is 1, 2, 3, 4, 5, and 6, right? And the total at the end of the box. So when the probability of x, when x equal to 1, the probability should be equal to 1 over 6, 1 over 6, 1 over 6 until the end. And the total probability is equal to 1, right? So this is the probability distribution for a balanced die, right? So if you want to find the expected value of gx, where gx equal to 3x squared plus 1, it would be the expected value of 3x squared plus 1, right? Right. So before we go to solve this problem, let's look at the expectation rule. The expectation rule, when we have expected of 3x, it should be equal to 3 multiplied with the expected of x. When you have expected of 3x plus 1, it should be equal to 3 multiplied with the expected value of x plus 1. Expected value of 3x minus 1, it should be equal to 3 multiplied with the expected of x minus 1. Now the expected value of 3, it should be equal to 3. Right? Expectation rule. The expected of 3x is equal to 3 multiplied with expected of x. Expected of 3x plus 1 is equal to 3 multiplied with expected of x and plus 1. When we have minus 1, we need to minus 1. When the expected of constant, expected value of 3 means 3 here means any constant. It should be equal to 3 as well. Right. So now, if you want to solve this problem, it should be equal to 3 multiplied with expected value of x power of 2 plus 1. So now, we need to find the expected value of x square. So the expected value of x square is x power of 2 multiplied with probability of x. So this one should be 1 power of 2, 1 over 6, plus 2 power of 2, 1 over 6, plus until you get 6 power of 2, 1 over 6. So this one should be equal to how much? 94 over 3, right? You can hear me, right? Okay, so this one is 94 over 3. So by using this value, just plug in the value into the formula. So the expected value of gx should be equal to 3 multiplied with 94 over 3 plus 1. So this one should be equal to, sorry, this is not a 94 over 3. What is the value? The ultimate value is 94 over 3. Right. Let's say this some value, right? So just input into the formula and then you will get 94.3. Right? If you have any question, you can put into group chat, right? Or you can voice up. So now let's move to the next section, which is variance for a discrete random variable. So when we have a mean, we should also have variance to know the actual distribution, right? So variance, the notation for variance is VAR X or Vx or sigma squared or sigma squared. Sigma square x or sigma squared, right? So we will use variance VAR X in this class, right? So by looking at the definition, to get X, to get variance of X, right? So the formula would be variance of X equal to expected value of X square minus expected value of X, then U squared. And you need to understand expected value of X square is not equal to the expected value of X then U squared. It's totally different value, right? So now, based on example number 4.3, we need to calculate variance of X. So from example number 4.3, we already know that expected of X is 1 and expected value of X square is 1.4. So now, expected value of X is equal to 1. Expected value of X square is 1.40, right? So now, to find variance of X, it should be equal to the expected value of X square minus expected value of X and then we squared this one. So this one should be 1.40 minus 1 power of 2, 0.40. Right. Are you okay? Now, just now we already look at the expectation rule. The expectation rule says that the expected of 3x is equal to 3 multiplied with expected of x, where expectation of 3x plus 1 is equal to 3 multiplied with expected of x plus 1. For variance rule, right? For variance, the expected of, the variance of any number, right? Variance of 9 should be equal to 0. Variance of, let's say, 3x is equal to 3 power of 2 multiplied with variance of x. Variance of 3x plus 1 should be equal to 3 power of 2 variance x, because the variance for constant is 0, right? And then variance of 3x minus 1, it should be equal to 3 power of 2 variance x, right? It's the same constant value constant. Let's say we look at this one. Let's say variance of 3x square plus 2x, right? It should be equal to 3 power of 2 variance of x square plus 2 power of 2 variance of x. Another one is variance of 3x square minus 2x. It should be equal to 3 power of 2 variance of x square plus variance, plus 2 power of 2 variance x. So pay attention on the minus and positive signs. A negative and positive signs is, if the value is positive, then it will be positive. If the value is negative, then it also will be positive. Right. So this is the variance rule. Right. So now variance, for the definition of variance we already look at. Division of variance. Variance equal to expected value of x square minus expected value of x, and then you square, right? So now look at example number 4.6, right? Given the probability distribution for a random variable x, and where x denote as the number of car sold by salesman weekly, right? So now we have x equal to 0, 1, 2, 3, and 4, means that number of cars sold by salesman weekly. So this is the probability value. Suppose that the salesman will get 250 ringgit as a fixed weekly income and 500 for each car sold. So the formula will be, the formula for income is y equal to 500 x plus 250. So we need to find the expected weekly income. So to find the expected weekly income, expected of y should be equal to expected of 500 x plus 250. So this one should be 500 expected of X plus 250. Right. So now we don't have the value of expected of X. So we need to find expected of X. So expected of X should be 0 multiplied with 0.05 plus 1 multiplied with 0.15 plus 2 multiplied with 0.35 plus 3 0.25 plus 4 0.20. So this one should be equal to how much? This is going to be 2.40, right? Okay, so once you get the value of 2.40, just plug in the value into the formula. So 500 multiplied with 2.40 plus 250. So this one should be equal to, it should be equal to 1450. So this is the average income of the salesman per week. Right. So next, we want to find the variance of Y. Variance of Y. So variance of Y is 500x plus 250. So this one should be 500 power of 2 variance of x plus 0. So next we need to find the variance of x. Right, variance of x is expected value of x squared minus expected value of x and then squared. Right. So expected value of x squared is 0 power of 2, 0 0.05 plus 1 power of 2, 0 0.15 plus 2 power of 2, 0 0.35 plus 3 power of 2, 0 0.25 and the last one is 4 power of 2, 0 0.20. So this one should be how much? Should be equal to 7, right? Okay. And then for variance of x, should be equal to 7 minus 2.40 power of 2. So this one should be 1.24. Right. So once you got the value of variance, right? So you just need to plug in into the formula of variance y. So this one should be 500 power of 2 multiplied with 1.24. So this one should be 31,000. Sorry, 310,000. So this is the variance of y. So remember, in this lecture, I am only focused on discrete random variable, right? Because we will have a test on this Friday. So we will cover until discrete random variable, right? So now, look at the question for practice time. Question number 2, right? Question number 2 says that given the following probability distribution function for a discrete random variable x, 2, 3, 4, and 5, and the total is equal to 1, right? Find the expected value of x and the variance of x. So this one should be very simple. X multiplied with probability of x. And this one should be 2 multiplied with 0.25 plus 3 0.25 plus 4 0.25 and the last one is 5 0.25. So what is the value here? Can you calculate for me and put it into chat group chat? It should be 3.5. Very good. 3.5. Right. So next, we need to find the variance of x. So the variance of x is equal to expected value of x square minus expected value of x, and then we square. So the expected value of x square should be equal to 2 power of 2, 0.25 plus 3, 0.25, 3 power of 2, right? Plus 4 power of 2, 0.25, and the last one is 5 power of 2, 0.25. Can you calculate for me? 13.5, is it correct? Right? 13.5. So next, we input the value into the formula of variance. X is 13.5 minus 3.5 power of 2. So what is the value? 1.25. Thank you. Right. Are you okay with this one? Right. Let's move to the question number 3. Right. This is a favorite question in final exam. Right. Find the probability distribution of X. The probability distribution of X is given as follows: 1, 2, 3, 1, 2, 5, and 9. So calculate probability expected value of X, expected value of X square. So it's the same procedure. So expected value of X is 1 multiplied with 0.2 plus 2 multiplied with 0.30 plus 5 0.40 plus 9 0.10, right? So what is the value? So this one should be 3.7. Thank you very much. Right. So the expected of X square. X square is 1 power of 2, 0.20 plus 2 power of 2, 0.30 plus 5 power of 2, 0.40 plus 9 power of 2, 0.10. So can you calculate for me? It's 19.50, right? Very good. So the next question B, this is A. B is expected value of 2 power of x square minus plus x plus 4. So this one should be 2 multiplied with expected value of x square plus expected value of x plus 4. So this one should be 2 multiplied with 19.50 plus 3.7 plus 4. So what is the value? Is actually berapa? 46.7, right? Thank you very much. 17. Right. Let's look at the last question for today, right? A discrete random variable x has a probability distribution of 5c over x for x equal to 1, 2, 3, 4, and 5. So find the value of c. So if, remember in chapter number 2, I say that the probability distribution can serve as a random variable can serve as probability distribution, right? when the summation of all probability is equal to 1. Another one is the probability should lies between 0 and 1. So to find the value of C, so you need to find the summation of C 5 over X equal to 1, from X equal to 1 until 5xi, right? So this one should be 5c over 1 plus 5c over 2 plus 5c over 3 plus 5c over 4 plus 5c over 5 equal to 1. Can you solve this for me and find C? What is the value of C? C should be 12 over 137. What is the value for decimal point? This is a fraction, right? Value for decimal point berapa? 12 over 137. So it's equal to 11.42. Is it correct? So somebody got 0.0876. Which one is correct? 11.42 or 0.0876? First, you need to exclude C, and then you will leave 5 over 1 plus 5 over 2 plus 5 over 3 plus 5 over 4 and plus 5 over 5. Should be equal to 1. Solve this one and bring to the right hand side, and we will get C, right? So it should be equal to 0.0876, right? Should be 0.0876, right? So next, we already know that the value is 0.0876. Let we make it into 2 decimal points, 0.09, right? So fx is equal to c 0.09 multiply with 5 over x. For x equal to 1, 2, 3, 4, 4, and 5. Right. So next question is, we need to find probability of x from 1 until 4. So by looking at this problem, this is B, right? So we want to find the value of probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Because this is not a continuous random variable. This is a discrete random variable. 4 is not inclusive. So 0.09 multiply with 5 over 1 plus 0.095 over 2 plus 0.095 over 3. So what is the value here? Can someone calculate? Zero point 825. Is it? Yep. Thank you very much. Okay. the next question is, we want to find the expected value of X. Expected value of X and the expected value of X square, which is the variance of X, right? To find variance of X, then we need to find the expected value of X square. So this is our objective for question C, right? So now the expected value of X is equal to summation of X multiplied with Fx, right? So when X equal to, this is X equal to 1 until 5, is it? Yeah, X equal to 1 until 5. Okay? So when X equal to 1, the probability of Fx equal to 1 is 0.09 multiplied with 5 over 1 plus X equal to 2, 0.09 multiplied with 5 over 2 plus 3, 0.09 multiplied with 5 over 3 plus 4 multiplied with 0.09 multiplied with 5 over 4 plus the last one is 5, 0.09 multiplied with 5 over 5. So this one should be 2.25, right? Very good. So the next step is we need to find the expected value of X square. So this one is the same process. We just need to square the value of X. So 1 power of 2, 0.09 multiplied with 5 over 1 plus 2 power of 2, 0.09 multiplied with 5 over 2 plus 3 power of 2, 0.09 multiplied with 5 over 3 plus 4 power of 2, 0.09 multiplied with 5 over 4, and the last one is 5 power of 2, 0.09 multiplied with 5 over 5. Can you get the answer for me? It's actually 6.75. Right. Very good. So next step is we need to find the variance of X. The variance of X is equal to expected of X square minus expected of X and then you square. So the expected of X square is 6.75 minus 2.25 power of 2. So this one should be 1.6875. Right. Remember, the value of variance cannot be negative. If you get the value of variance is negative, then something wrong somewhere. Right? You need to recalculate. Right? The variance should be positive value, also with standard deviation. Right? So the last question is the D. Question number the D is expected of 2x power of 2 minus 2x plus 3. Right. So this is the question, right? 2x power of 2 minus 2x plus 3. Right. So this is very simple, straightforward. 2 multiply with expected value of x square minus 2 multiply with expected value of x plus 3. So this one 2 multiply with 6.75 minus 2 multiply with 2.25 and plus with 3. So what is the value? Is equal to 12. Right. Very good. Right. By this question, we already finished our lecture. Right. We will continue the next topic, which is expected value for continuous random variable, a moment and moment generating function on the next lecture. Right. By now, we should only focus and master chapter number 1 until chapter number 4, expected value for discrete random variable. Right. So, do you have any questions so far? You can voice out or write into a group chat. Any question? So if you don't have any question, then we will meet tomorrow and discuss maybe a lot of our discussion tomorrow is about past year question, right? So we will do a preparation for test number 1 on Friday, right? So your location test number 1 is at where? DK 200 or auditorium? Auditorium, right? Is it? Yep. Okay, good. So if you don't have question, we should end here, right? I will post this video into YouTube. Then if you still not, you cannot catch up for today lecture, then you can rewatch the lecture in YouTube, right? Okay. Till then, Assalamualaikum.